Hi, Tim Shue from San Jose State to talk about related rates, and there's not much to say, so let's go for it. Well, I'll talk about the basic idea of what related rates and do an example. All right, so the basic idea of related rates is suppose we have the situation, we have a number of quantities, call them like x and y or whatever, that are all functions of time. And suppose that those quantities are related by some equation. See what I did there? Yes, related rates, because the quantities are related. And so the basic idea of related rates is to take the derivative with respect to time, thus the rate part of both sides of the relation equation, and in order to solve for dx dt or dy dt, or figure something else out about dx dt or dy dt, or x or y or whatever. The actual problem will depend heavily on what word problem, and yes, they're all word problems you're given, but that's the basic idea. You set up a relation and you take the derivative of both sides with respect to t. So here is a very concrete example. So suppose we have a bug. Yeah, it's always bugs, right? But for a lack of creativity, this is not a super interesting or super practical word problem. But suppose that you have a bug that travels around the circle of radius 5 centered at the origin. So there's your bug right there. And suppose at some given point in time, the bug is at the point 3, 4, and its x-coordinate is decreasing at the rate of 2 units per second. At what rate is its y-coordinate increasing or decreasing? So, answer. Well, let's try to turn all this English into math. So this first sentence tells us that we have the circle of radius 5 centered at 0, 0. And as you may remember, the equation of that is x squared plus y squared equals 25. And we are given that x equals 3 and y equals 4 because the bug is at 3, 4 at this particular point in time. And that dx dt is minus 2 because the x-coordinate is decreasing, that's where the minus sign comes from, at the rate of 2 units per second. And the point is, where the last sentence says at what rate is its y-coordinate increasing or decreasing. In other words, solve for dy dt. Okay, here's the one sort of most interesting calculational part. So we have this relation x squared plus y squared equals 25. So when we take the derivative with respect to time of both sides of that relation, we get 2x dx dt plus 2y dy dt is equal to 0. And where do these extra terms come from? Those extra terms appear because, remember, we're assuming that x is a function of time, as is y, and so we get this extra term because of the chain rule. All right, anyway, getting back to solving the problem, we have achieved this equation, and so plug in x equals 3 and y equals 4, and dx equals t equals minus 2, we get this. 2 times 3 times minus 2, so x is 3, dx dt is minus 2, and y is equal to 4. So simplifying that a bit, we get minus 12 plus 8 dy dt is equal to 0. Adding 12 to both sides, we get 8 dy dt is equal to 12. Dividing both sides by 8, we get dy dt equals 3 halves. And so we conclude that the bug's y-coordinate is increasing, and it's increasing because the sign is this right-hand side is positive, at the rate of 3 halves units per second. Da-da-da! All right, we're done now. Okay, thanks, bye.